Okay, so welcome and thank you. I'm going to be talking about VCL, the ValueSet.compose language. A little bit about myself. This should be the least interesting slide in the deck. I'm from CSIRO, so it's National Science Centre, and I've been heavily involved in the FHIR terminology services specification and lead developer for AutoServer. So a little bit of history about VCL and where we've been and where we've got to. The core of it is motivated by SNOMED's expression constraint language, so ECL, and I'll talk in more detail about ECL in the coming slides. And then we've had some requests for additional capability in the ValueSet compose semantics characterized in this ticket, ostensibly asking for being able to filter based on the labels on terminology codes, but broadening out into some deeper requirements that have led to the desire for a user-friendly or URL-friendly syntax shorthand for what you can express in a ValueSet compose. So last year's DevDays, I introduced a proposal for VCL. Since then, we've had some feedback. One of the key things being that it can't be more expressive than ValueSet.compose, so we can't add in additional expressive power, something I'll address, because the requirements, that initial requirement there is additional expressive power. So it basically means we have to extend the expressive power of compose. And that the syntax can be simplified. So there were some people playing around with it and some confusion about how things worked, and so we looked at simplifying the syntax. So the foundation of this really is SNOMED's expression constraint language. So for those of you who were in John's talk, you saw a really nice explanation of how codes can have properties and relationships and how useful they are for analytics and other things, and in value set definition in particular. So with ECL, we have a query, effectively a mini query language that's tailored towards SNOMED, but really is a terminology-oriented query language. So it has simple syntax for hierarchy traversal, going up and down the hierarchy, for matching the values of properties, for navigating across relationships, so going from one code to another, and also for reference set membership. So in SNOMED land, a reference set is like a value set. So you can say, find me all the codes that match these criteria and are also in that reference set, or analogously in that value set. So those are the core features. And then ECL is actually exposed through the FHIR terminology API, and it's exposed in two places. You can use it inside the compose, so you can have a filter called Constraint, and then the value of that filter is your ECL expression, and it says match all codes that match this ECL expression. But you can also use what's called an implicit value set. So this is the pattern for an implicit value set. It's basically a bit of boilerplate at the beginning, followed by the URI encoding, so with percents and so forth for special characters of the ECL expression. And then you can pass that directly to an expand and say, expand me this value set defined by this ECL expression. That's really handy because it's really easy for tools to define those on the fly. And because you're using a GET request, it's cacheable, so you don't have to make up a value set resource and then post it. So it's both convenient to use for developers, but it's also really good for the infrastructure. So it's a really valuable approach for dynamic value set use cases, and for all the sorts of analytics scenarios where you're doing this kind of value set definition on the fly. So we have a set of goals and non-goals for VCL. It needs to be easy easy to read and write. So the suggestion there is to borrow from ECL and be inspired by that syntax. It needs to be compact, so that's kind of runs a little bit counter to the easy, because you can be easier if you're more verbose. It needs to be URI friendly, and that also runs a bit counter to the easy to read and write, because you want to avoid generally the need for including white space, and we do need to avoid some special characters, but it sort of pushes us in a particular direction, like using symbols to represent and or rather than the words and or. So that sort of drives some of the design criteria. But you can get a fairly compact and relatively readable language out of it. So some non-goals, completeness with respect to ValueSet.compose. So we're not trying to design a language that you can express everything that you can express with a ValueSet.compose. In particular, we're not trying to deal with multi-code system value sets. We're not trying to deal with explicitly the issues around use of supplements and some of the corner cases. It's really about the core, straightforward things that are simple to do. Otherwise, we would end up with a really complex and verbose language that 90% of people would never use. So it's a bit of an application of that kind of 80-20 rule. We're also not trying to get expressive parity with ECL. Really, ECL is just a jumping off point. And so we're not trying to get expressive parity there. We're not even trying to get syntactic compatibility. So those are non-goals. So intuitively, what does the language look like? Well, in a compose filter, you have the property, the operator, which is one of a fixed set of operators, and a value. So those are the key parts. And some of the key things that you want to do are hierarchy traversal. In the filter, that would be something like code with the operator isa, and then an explicit code as the value. But we introduce the less than and greater than symbols to do traversal up and down the hierarchy, either including the starting concept or excluding the starting concept. So the double less than means more things, so it's the including one. A syntax for and or, so that's comma for and semicolon for or. Some quoting rules. So in SNOMED it's easy because SNOMED codes are just strings of digits, and so there's no ambiguity when parsing. In a general FHIR CodeSystem, a code can be any sequence of characters that doesn't start or end with white space. So we need to be able to work with things that might collide with other parts of the language. So we introduce single quotes to resolve any ambiguity around there. And then we have some other features. So path navigation. So this allows you to basically follow a property, like ingredient of, to get the codes that are the ingredients of, so the results of relationships. And then you can string those together. And I'll show you some examples in a moment. Yes?
How about not and grouping? Not operation and grouping, because the part of VCL
Well, I can talk to that at the end, yeah. Term filtering, obviously that was one of the initial requirements of the ticket. And then value set membership as the analogy to reference set membership. And then some of the changes, things that we've added as a result of feedback, support for nesting of expressions. So originally VCL was a kind of a single level expression language. Now we look at nesting. More detailed term matching, so actually being able to filter on the use, display language and so forth. And then removing some of the quirks that we introduced, syntactic quirks that came from ECL, which is for anyone who's looked at VCL, the colon syntax. because it's already essentially covered in the semantics of AND. We also propose implicit value sets. So here the idea is you take the CodeSystem URI, you add a little bit of stuff in the middle and put the VCL on the end, and that gives you a way to have implicitly defined value sets for any code system using VCL that you can pass to expand. So here's the syntax. This is for people who download the slides. And so some examples. So obviously, degenerate case, just a single code. So here we've got caffeine. That matches caffeine. We can match all the codes which have an ingredient of caffeine. So this is just has ingredient equals, and then the code for caffeine. And so you can see here, this is the sort of model of the underlying terminology. So we're just navigating across a relationship there. We can do multi-hop. So if we want to get the actual products, then we want the products that consist of something that has an ingredient that is caffeine. So that'll match those products. And then we've got this sort of, you can do the nesting. So maybe we don't know what the ingredient of no snooze is, but we want the products that are like no snooze. So we want all the things that have the ingredient that that has this trade name. And so you can do arbitrary levels of nesting there. And so this is things that have ingredient caffeine and have dose form oral pill, or you can even put the descendants of, so we can say all the things that are in pill form, so all the different types of pills. So you can get quite powerful queries and matching expressions there in a very compact and relatively readable syntax. You will notice though that this readability of the syntax is limited by the readability of the codes themselves. So something that for writing them you would solve or address with tooling. So quick summary of all the different kinds of forms. So code itself, hierarchy traversal from a code or an expression. Star matches anything, so sometimes you need a placeholder that is any code. Property matching. The properties correspond to the filters of the code system, so you get things like parent and child and code implicitly defined. So that all just follows through from the underlying code system. String valued things, of course, and numeric valued things. So all the types that the properties support. The nesting, so bracketing for grouping things to make semantics a bit more explicit. And then some more fancy matching. So here we see an example of code colon regex or property colon in, and these the colon whatever corresponds to the filters in the filter names from ValueSet.compose. And then lastly at the bottom there is the value set membership syntax. So that's the colon in, and then the less than greater than to sort of quote the URI of a value set. So we have some limitations that come from value sets. So this is the gap between the expressive power of VCL and the expressive power of ValueSet.compose. So designation filters, we need to extend ValueSet.compose to be able to filter on designations. The membership, we need to have a syntax for membership, so we probably need to add a new filter like member of for that. And then the property navigation thing where you go, all the ingredients of a code. There's no way to express that in a value set definition unless you've got the reverse filter defined. So we need to implicitly have implicit definition of those reverse filters. So there's some uplift of the value set specification that we'll need to get in for R6. There are some additional filter operators that were introduced in R5 that weren't considered for the VCL They don't add expressive power. Whether or not we push them into language, I guess, depends on demand and feedback. And then, of course, the things I already mentioned, multi-code system value sets are out of scope. We don't address code system supplements themselves. So, where to from here? We have a proof of concept implementation, our Onto Server Sandbox URL there, you can go and play with it. So using the implicit value set definitions, you can expand things. There's a thread on Zulip, so if you have any feedback, if you want to know more, you can jump on that thread and ask questions or provide feedback. Please have a play if you're interested, and looking for feedback there. I should give a shout out to Josh. He provides some really good feedback and helped with improving some of the syntax. He's got his own experimental implementation that you can play with there. And he's also proposed some extended syntax. Don't know really whether we need it or not. It might just, it doesn't add expressive power to the language, but it might make it slightly more usable for certain use cases. Places you can provide feedback directly to me. And thank you for your attention.
Thank you, Michael. Any questions? Yes.
Thanks for the interesting talk. I actually also like the SNOMED on FHIR talk on Monday. My question was that is this going to be a core capability for terminology servers to support implicit value sets and VCL going forward?
I would really like that to be the case, yes. So in principle, yes. Something like this will be coming because we have a mandate to resolve that ticket. And this is the work in progress resolution to that ticket. It'll be something like this, I expect, yeah. The challenge then is how many terminology servers actually implement it. I imagine that Graham will implement it. We certainly will. There's been limited support actually for ECL in terminology servers, so there's a tension. You may not get it in all implementations. But one of the things is the expressive power is not really that different to value sets. So you can take, the idea is you can take the VCL, transform it into a set of value sets sort of under the hood, and then just use your normal logic. The terminology server can use its normal logic to evaluate.
No more questions? Oh, one. Yeah.
What, syntactically or? They're on a par. So SNOMED has some things in the language that don't exist really. So reference sets, for example, reference sets in SNOMED aren't just simple ones are just lists of concepts, but complex ones represent maps or other tabular information. So ECL lets you interact with and access all that kind of thing. ECL also has recently added a whole lot of deep support for basically interacting with designations, filtering on designations in different ways, which there's some analogy here with VCL, but not as far. And then I guess the other bit is that SNOMED has metadata associated with the codes to do with what module they were defined in, when they were last updated and so forth. That metadata doesn't exist in FHIR, so there's no way to surface that. Otherwise, all the features are pretty much analogous. The set of operators are different, so the regular expression matching on a code you can't do in ECL. So there's some features that come from value sets that percolate up that don't exist in the SNOMED world. But the idea is that you can use VCL with SNOMED if you want to do that.
Okay, thank you very much, Michael. It's time for coffee.
Okay, thank you.